We've been using silver to fight germs for, well, centuries. But what happens when you take that same silver and shrink it down, way down, to the size of a virus? That's what we're diving into today. How nanotechnology is turning this old school remedy into a super powerful new weapon against some of our scariest viruses. So that brings us to the big question, right? Could something ancient, something we've known about forever, actually be the answer to our most modern problems? I mean, defeating viruses that are literally outsmarting our best medicines? It's a wild thought, but it could be a total game changer. And let's be clear, the stakes here are incredibly high. We're in this constant fight with viruses, and honestly, they're really, really good at it. They evolve, they adapt, they develop resistance to our drugs. It means we're always on the hunt for brand new ways to fight back. Okay, so before we jump into the solution, we really need to get a handle on just how big this problem is. Because we're not just fighting a single enemy, we're up against a threat that's constantly changing. Think of it like this. Viruses are just masters of survival. They're relentless, they're mutating all the time, which lets them do things like jump from animals to people. And, maybe most importantly, it lets them build up resistance to the very drugs we create to kill them. So we're not fighting some stationary target. It's a full-on arms race against an enemy that never stops changing. That's how we get new threats like SARS, or why the flu is a problem year after year. So with a challenge like that, where do you even begin to look for a new weapon? Well, the answer is kind of surprising. It's something ancient, but it's been totally reimagined with some cutting-edge tech. And that tech is all about the nanoparticle. Okay, so what is that? A nanometer is 1/1000th of a meter. It's tiny, impossibly tiny. And when you shrink a material like silver down to that size, something amazing happens. Its properties totally change. The main reason is you get this massive increase in surface area compared to its volume. All that extra surface makes these tiny particles way, way more reactive and powerful than the big chunks they came from. So let's compare. You've got regular bulk silver, the stuff we've used for ages. It works okay, mostly by slowly letting go of silver ions that kill bacteria. But then, you've got silver nanoparticles, and these are a whole different animal. Because of that huge surface area we just talked about, they can physically get in there and neutralize viruses in a way that a big piece of silver just can't. It's not just a souped-up version of the old stuff. It's a brand new power, a new antiviral capability. Okay, so how does this attack on the nano level actually work? How do these tiny particles take out a virus? Well, to figure it out, scientists looked at how they work against the HIV-1 virus, and what they found was pretty incredible. First, let's get the baseline. Here's how HIV usually gets into a cell. The virus has these little proteins sticking out of it. They're called GP120. Just think of them as keys. And our immune cells have special locks on their surface, called CD4 receptors. The virus's key is designed to fit that lock perfectly. Once it clicks in, the virus can merge with the cell and start its hostile takeover. And this is the breakthrough moment. What the research showed is that silver nanoparticles latch on directly to the virus's GP120 keys. They physically stick to them, which means the virus can't use its key anymore. It can't connect to our cells. The infection is literally stopped in its tracks before it can even begin. So let's stick with that key and lock idea for a second. The virus has its key, that GP120 protein, and it absolutely needs it to get inside our cells. Then, in come the silver nanoparticles. They're like this tiny swarm that just descends on the virus and physically covers up all of those keys. They basically just gum up the whole mechanism. The result? It's simple, but it's so effective. With its keys all clogged up, the virus is just neutralized. It's left floating around totally harmless because it can't dock with and infect anything. The nanoparticles are what we call a virucidal agent. They kill the virus particle itself. But it gets even better. The attack doesn't just happen at the front door. If any nanoparticles make it inside the cell, they can also mess with the virus's ability to make copies of itself. This is a huge deal. It's a multi-pronged attack. You see, a virus might be able to evolve and get around one line of defense, but trying to evolve around multiple different attacks at the same time, that is so much harder. And that gives this approach a massive leg up on our usual drugs that only have one target. Okay, so we know it works incredibly well against HIV. But is that it? Is this just a one-trick pony? Nope, not even close. The evidence shows this could work on a whole lot more. I mean, just look at this list. we're not just talking about HIV anymore. Studies have shown it's active against herpes, RSV, hepatitis B, even monkeypox. Now, the exact protein key it targets might be a little different for each virus, but the basic idea is the same. It creates a physical blockade, stopping the virus from ever getting into our cells. That's exactly what you want in a broad-spectrum antivirus, a single weapon that can fight a whole bunch of different bad guys. And let me just hammer this point home. This isn't just the silver doing the work. There's this measurement called the therapeutic index. It's basically a score of how good a drug is at killing the bad stuff versus how much it harms the good stuff, our cells. Well, for silver nanoparticles, that score was more than 12 times higher than for plain old silver ions. The nano part isn't just an improvement, it's what makes this whole thing possible. But, and you knew there was a bot coming, with any technology this powerful, you have incredible promise, but you also have to ask some very serious questions. We have to talk about the potential downside. I know, it sounds amazing, doesn't it? A weapon that works against tons of viruses and is hard for them to resist. It sounds almost too good to be true. So, what's the catch? Well, the promise is huge, for sure, but the risks are also very real. See, the very thing that makes these particles so effective, their high reactivity, is also what makes them potentially dangerous. That same power could be turned against our own cells. It can create these nasty, unstable molecules called reactive oxygen species, or ROS, that cause cell damage. And the simple truth is, we just don't have a lot of data yet on what these things do to our bodies or the environment in the long run. And that brings us to the most important next step. Before this technology ever becomes a common treatment, we need a ton of safety research. It's not optional, it's essential. We have to be 100% sure that this powerful new weapon is only targeting the virus and not us. So let's zoom out. Why does all this matter? Why is it so important? Because we are always looking for new tools in this fight. Think about all the viruses out there with no vaccine. Think about the superbugs that have become resistant to everything we have. Nanotechnology offers a completely different way to attack them. It could be a whole new class of medicine for a fight that's as old as humanity itself. And that really leaves us with a pretty cool thought to chew on. As we look ahead, maybe the biggest breakthroughs in medicine won't come from discovering bigger and more complicated drugs, but from learning how to control and build things at the absolute smallest scale we can even imagine.